So this is section 11.1 sequences, and this pretty much is going to be a very long chapter, and it's all based roughly on this section and the next section next on top of it. Okay, so first off, what in the world is a sequence? You kind of think of it when it's a sequence of numbers. So essentially, like say 3, 5, 7, 9, 12, 15, and so forth, right? Just a sequence of numbers. Okay. Now, how the sequence of numbers is illustrated does actually matter in this case. So how we say this is a sub 1, a sub 2, a sub 3, a sub 4, dot, 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 all the way. So we label each one of these numbers as like the first sequence, first number sequence, second, third, fourth, fifth, and so forth down the line when it comes to it. That way the last number is called a sub n, right? The last number in our sequence itself. Okay. And what a sequence ends up being is roughly the same thing. Any function can be returned to a sequence just by changing f of x to a sub n instead. So, for example, if we have a function looking like this, we can now convert it into in a sequence just by replacing x with n and f of x with a sub n. It's that simple. Okay. Now, for example, now we can find the first term of the sequence, second term, and so forth, just by replacing or plugging in what a is to begin with. So, for example, if you want the first term, that means you plug in 1 in for n. So 3 times 1 is 3, plus 1 gives you 4. A sub 2 means you plug in 2 for the sequence, so second term. So that's n squared, so that's going to be 4 times 3 is 12, plus 1 is 13. And we keep going. So 3, that's 9, times 3 is 27, plus 1 is 28, right? And we keep going when it comes to. And this is what, what a sequence function, if you want to call it, looks like itself. Okay? Now, the reason why this is important is what we're going to be doing pretty much for the entire chapter is these sequences either go to a single number or they just don't go to a single number. So what I mean is that converge or diverge itself. Okay? Now, this is a key thing when it comes to our definition of a sequence. It says a sequence a sub n has a limit L such that if we take the limit of this entire sequence and we can find a number, right? That's the key thing. If we can find such a number that does exist, therefore we say the sequence converges to that number, or just converges. Meaning eventually as it goes to infinity, it touches one single number at infinity itself. If we cannot, then we say it diverges. So those are the key things the core of this entire chapter of chapter 11 itself. Figuring out does one sequence converge or diverge, and we're just going to be given different scenarios and figuring out how to do it. So before we actually do that, that's going to be the main definition of it. There's a couple little scenarios when it comes to limits. So it's been a while since I just gave you guys a quick little lesson, a review about the limit itself, right? So if the limits of two different sequences, that means you could take this limit of individually and add together. If it's a constant term, you can bring it on the outside, things like that, right? So a lot of stuff you guys probably forgot from basic or from last year's calculus class. I just put in just references, right, when it comes to it. Okay. This is a key one we're going to be doing a lot, especially when it comes to it. Okay. Now, here's a very interesting one. We're actually going to be using this a lot as well. The sequence r to the n, okay? So a number raised to an x value, okay? Or, yeah, you could call x. So you could kind of do like 5 to the x as our sequence here. The sequence r to the n converges if the r value itself, so this number right here, is between -1 and +1, okay? Strictly greater than -1, and it could equal 1 as well, okay? It diverges for all other values in this case, okay? So, for example, here it would diverge because 5 is greater than 1, right? So it diverges. So that's the situation we have here. That's going to be a key thing as we go forward. So whenever you see something like this, you automatically just look at the value of r and see if it diverges or not based off that. Okay. Now, if r is between here, the limit automatically goes to 0. If r equals 1, the limit equals 1. Okay? So it's going to be one or the other if, that's if r is between those two numbers themselves. Okay? Again, so we'll talk about that in a little bit. So But first, we're going to do a little bit more difficult stuff. And this is, this is what hard stuff is. When I was taking this class, this is one of the most difficult ones to deal with when it comes to this, is going backwards. So like, what if they gave you the sequence itself like this, and they wanted you to generate what it looked like to begin with? And this is pretty difficult. It's a lot of finesse when it comes to it. And, I want to give you guys be experts right off the bat. Just lots of practice when it comes to, and just, knowing, what the properties are, and, multiplication, division, all that fun stuff comes into play. Okay. So this one we want to convert. So the sequence is 4, -1, 1/4, -1/16, and so forth. So hopefully you notice, okay, it's going by 4s, right? That's a good thing. So we have our starting point there. Okay. And we're actually dividing somehow by 4, right? So we know each of these is going to be divisible by 4, which is good, right? We're just dividing by 4 all the way down. So we kind of have an idea there. As you also know, they're actually changing sign as well, right? So one's positive, one's negative, one's positive, one negative. So we know it's going to be somehow looking like this, and like that, right? Because we're divided by 4. And that's actually a really good sign. If you got that far, that's pretty good. Now, the next thing is, how do we get the exact values, right? So remember, this is saying your first term is 4, your second term is -1, your third term is 1/4, and so forth. Okay? Meaning, if I plug in 1 in for n, I should get out 4. If I plug in 2 in for n, I should get -1. Okay? Now, unfortunately, if I plug in 1 in for n, that gives me -1. That can happen, right? So we may have to actually do this, because I guarantees it now to alternate. Because if I plug in 1, that's 0. -1 to the 0 power is positive 1. Plug in 2. 2 minus 1 is 1. Gives you negative. Plug in 3. That's squared. And notice we got that pattern going down. So it looks like we got this solid down. We got the negative alternating stuff. But now how do we get this kind of stuff here? Okay. Well, first term has to be 4, right? So you think, okay, well, why don't we just plug 16 in, right? But remember, it has to be a function of n. So right, we're going to plug in, and we're just going to get down first. So it can't be 16, because somehow this has to get bigger to decrease these values here, right? So let's suppose this was also n. That might work there. Okay? Because if I plug in 1, well, that gives me 4. So 4 gives you 1. That's not good. That means I got a section option here, right? But notice this little trick I gave you guys, right? So what if we just drop it from 1? Now, does that work? Well, if I plug in 1 now, that gives me 0. 4 to the 0 is 1, so perfect. Gives you 4. If I plug in 2, 2 minus 1 is 4. 2 minus 1 is 1. We get 1. Perfect. Let's try it again. Plug in 3. That's 4 squared. That's 16. 4 over 16 simplifies to 1/4. Hey, looks like we got our pattern essentially. So how you write this now is going to be a sub n is equal to -1 to the n minus 1 times 4 over 4 to the n minus 1. And it looks like that's going to be your pattern itself. Okay. Now you can make it this a little nicer when it comes to it. So for example, you could do it like this, but it's it's pretty fine how it is already. That's an alternative. You could see it as well when it comes to it. And this is kind of the way they prefer, because as we do the take limit, notice here, right? So if I have this value, r is going to be, in this case, -1/4 when it comes to it. And therefore, it might, actually, well, when we plug this in, well, it did kind of diverge. So this would be 0, right? So it diverges. Converges. So that's kind of how we want to simplify it. So once you guys can see examples, we want to make this look like this somehow. That way you can follow that template itself. So I know this is pretty difficult. So let's try one that's not as difficult itself. Okay. So let's try this one. So 5, 8, 11, 14, 17. Okay. So if you notice the pattern, looks like we're just adding 3 all the time. Right? We're just going by 3, so we just add 3, add 3. So we have an idea of the next one, right? So this next one should be 20, then 23, and so forth down the line. Okay, so The key thing is, remember, going back way back to what addition is. So remember, addition is essentially a product of multiplication, right? So for example, if I add 3 plus 3, that gives me 6. A shortcut is 2 times 3 gives you 6. If I add 3, 3, 3, that's the same thing as 3 times 3, right? So that's what's happening here. So if I'm adding 3 all the time, I mean it's going to be a multiples of 3 themselves. So kind of like this at that point. But kind of not, right? So if I have 1 here, that's going to be 3, not 5. But this is going to be 2, that's going to be 6, not 8. This is n equals 3, that's 9, not 11. But do you notice what's missing? If n equals 1, that's 3. If n equals 2, that's 6, 9, 12, 15. And if you notice, the only thing that's missing from what we have here is just a 2. Right? We just add 2 to 3 gives you 5. Add 2 to 6 gives you 8. So, in fact, we are almost half right. We just needed that extra 2 to add. And there's our sequence. So a sub n is equal to 3n plus 2. And there's our sequence there. Again, these are pretty difficult. I wouldn't expect you guys, right off the bat. But again, a little bit of practice and a little finesse, and you'll be perfectly fine for those. Okay? Now, with the main topic of what we're dealing with and going on for pretty much the rest of this chapter is this kind of stuff right here. Determine whether each sequence converges or diverges. And we're going to use a definition of it itself. And just in case you forgot, we're going to be using this one here. If we take the limit of the sequence, and if that value does exist, then it converges. If it doesn't, it completely diverges themselves. Okay? So that's what it means. So converges means it actually goes to a number. Divergent means it does not go to a number. It just goes to negative or positive infinity. Converges means it actually goes to a single number as, the limit goes to infinity itself. Okay? So let's try this. So we're going to take the limit as n goes to infinity of our sequence. Okay. Now you may be wondering where we even start, right? But one little thing when it comes to calculus, the first part of calculus, is you guys learned how to do L'Hopital's rule. Now, just in case you guys forgot what L'Hopital's rule is, if you take the limit of a function, that's just this value, and if this goes to infinity over infinity, right? So if I take the limit of the top and the bottom, if they both go to infinity. So that's the reason why I said we're going to be using this one a lot, because we're going to take the limit of top and bottom individually. And so if this happens, you actually take the derivative and then redo it again. And that's exactly what we're going to be doing here. So if you notice, if I plug in, if I go to infinity, this goes to infinity. If I just, plug in a huge value and it keeps going, it also goes to infinity. So L'Hopital's rule does actually work. So this also implies if you have, n goes to like a value, if you have 0 and 0, but in most cases we're going to be using this when it comes to it. So using L'Hopital's rule, meaning we take the derivative of the top and the bottom individually. That's a nice thing, right? Never, always separate, so we don't have to use product rule. So just take the derivative of the top, gives you 10n. The derivative of the bottom gives you 1. So the limit as n goes infinity is literally infinity, right? It just never ends. So therefore this diverges because it doesn't go to a single number. Okay, let's try the next one. So take the limit as n goes infinity of 2 plus 0.86 to the n power. Okay. So notice, 2 is fine, right? There's a value, so that's going to be 2. The limit of 2 is just going to be 2. But what about this one here? Now this is where our nice special sequence comes into play. This says, right, we have 8.6 to the n power, which correlates to this. If r is between -1 and 1, it converges. And not only does it converge, it converges to 0. If r is 1 itself, it equals 1. So notice that we have this situation happening there. 0.86 is between -1 and 1. So therefore, the limit is actually 0 itself. So if we go back over here, this is equal to 2 plus 0, or just 2. So it goes to a single number, so therefore this converges. And that's how we're going to use all these rules to help each other out. So you may want to use the flashcards, especially for these coming up sections as well, because they're pretty hefty. Okay. All right, let's keep going. So take the limit as n goes to infinity of all of this, and we're just going to do this instead. Make it easier. Okay. Again, right, if I take the limit of the top individually and the bottom, it actually goes to infinity, right? It goes not too much, but it still goes infinity because, square root. So we can use L'Hopital's rule and take the derivative. So derivative of this is going to be 3 over 2 n to the -1/2 over, that goes away, right? This is just going to be 1/2 n to the -1/2. Okay. Oh, look at that. Notice it actually cancel away, right? So if we want to rewrite this, when it comes to this goes to the top. Well, actually, this stays in there. That goes to the top. That stays at the bottom. And then this goes to the bottom. So they just swap places, but notice they cancel out. So this ends up being whatever 3 over 2 divided by 1/2 ends up being, which is usually in proper fraction. So we just simply divide it. So it's going to be times flipping exactly 3. So limit is equal to 3. Perfect. Right? That's a number. So therefore it converges. Right? So in this case, there's just lots of algebra to find the value. Okay. And there we go.